This is our bear named Teddy. Teddy is holding a unit circle. On the unit circle, we can see degrees, radians, and coordinates. We can use degrees, radians, and revolutions to measure how far we go around the unit circle. When looking at the radians of a unit circle, we can see that if we start at 0 radians and go all the way around, we will have traveled a total of 2 pi radians and end up at the same place as we started. This travel can also be labeled as going 360 degrees around the unit circle or 1 revolution around the unit circle. When measuring things in units of 1 unit circle, we use revolutions. If we travel a quarter of the unit circle, or 0.5 of a revolution, we would have traveled half a pi in radians. If we traveled half of the unit circle, or 0.5 of a revolution, we would have traveled pi radians. If we traveled 3/4 of a unit circle, or 0.75 of a revolution, we would have traveled 3 pi over 2 radians. If we traveled all the way around the unit circle, we would have traveled 2 pi radians, or 1 revolution. We can find the coordinates of the unit circle at 30 degrees by using a 30, 60, 90 triangle. We can do this because we know that the radius of the unit circle is 1, being from here to here. And at 30 degrees, we know that there is a 30, 60, 90 triangle, which is from, this would be 30 degrees, this would be 60 degrees, and then there would be 90 degrees right here if we drew a line from here straight down. If we were solving this triangle for the other two sides, we know that the short side is half of the hypotenuse, and we know that the hypotenuse is 1, so this short side would be 1 over 2, and we would know that this last side right here would be the short side times the root of 3. This gives us that this side right here would be the root of 3 over 2, and the short side over here that goes up and down would be 1 over 2. This matches our coordinates here, which proves that we can use the 30, 60, 90 triangles to solve for the coordinates on the unit circle. We can use a 30, 60, 90 triangle to solve for the coordinates at 30, 60, 120, 150, 210, 240, 300, and 330 degrees. This is because if we just take this triangle and flip it, we would come up with the same triangle right here. "45, 45, 90 triangles can help us find the coordinates on the unit circle for 45, 135, 225, and 355 degrees. If we look at 45 degrees, and we know that the hypotenuse would be 1 because the radius of the unit circle is 1, so we know from here to here is 1. And we know that the hypotenuse of 45, 45, 90 triangles are the root of 2 times the length of one of the other sides. So if we take 1 and divide it by the root of 2, we would find out that the other sides, being from here down and from here to there, would be the square root of 2 over 2, which would match the coordinates on the unit circle. There are many patterns found in the unit circle. If we look at the denominators of the radians starting at the x-axis, it would always follow the pattern of going from 6 to 4 to 3 to 2. Any way you look at it, starting from the x-axis going towards the y-axis. Still looking at the radians, but now the numerators. In the first quadrant, the numerator is always a lone pi. In the second quadrant, we can see that the numerator is 1 less than the denominator times pi. So over here, it's the denominator is 3, so the numerator is 2 times pi. And then in the third quadrant, the numerator is 1 more than its denominator times pi. So over here, it's the denominator is 6, so it's 1 more than it, 7 times pi. In the fourth quadrant, the numerators can be remembered as 5 days a week I go to 7-Eleven. This is because if we read it from left to right, it's 5 pi, 7 pi, 11 pi. 5 days a week go to 7-Eleven. Tangent equals sine over cosine, and the reciprocal of cosine has the same distance from the y-axis as normal cosine.
Each of the trig functions' graphs are shown on the unit circle. So for example, sine will have a maximum at pi over 2, a minimum at 3 pi over 2, and an x-intercept at pi. At pi, sine, or the y-axis, or the y, is equal to 0, which is why it's an x-intercept. At pi over 2, sine is equal to 1, which is why it's a maximum point. And at 3 pi over 2, sine is equal to -1, which is why it's a minimum point. Cosine, on the other hand, is the complete opposite. So at 0, it has a maximum, and at pi it has a minimum, and at pi over 2 it has an x-intercept. So at pi over 2, cosine is equal to 0. At 0, cosine is equal to 1, and at pi, cosine is equal to -1. And this is all reflected on the graph. Tangent also follows this, because as we know, tangent is equal to sine over cosine. So for example here, the tangent would be 0 over 1, which equals to 0, because it's 0 over a number. And the tangent graph shows over here that there's a point at 0. Now an asymptote of tangent is pi over 2, right here. And on the unit circle, you see that at pi over 2, tangent is equal to 1 over 0, which, because it's a number over 0, it's equal to undefined. So there's an asymptote there. Yeah, so there's an asymptote. Other than that, the unit circle can be used to translate or convert radians into degrees. So if you want to know what pi over 4 radians was as degrees, you can find that there. Or if you want to know what 3 pi over 4 radians was as degrees, it's right there. And so it's really helpful with that. Or even like pi over 2, you can see it's a quarter of a revolution, because it's the quarter of a circle. Also, when graphing the inverse of sine and inverse of cosine, which is this and this, the unit circle helps, because if you limit the unit circle to one side, for example, this would be for sine and tangent, it can show you where the points of the graph would be. So you have to limit it, because with the sine inverse of sine graph, it passes the vertical line test. Like there's no point where if you went from like the top to the bottom of the graph, there would be 2 points to intersect. So you need to have an area where there's all different sine points, or points of sine, and so you have to limit it. The same goes for cosine, but instead you have to limit the bottom half of the circle, and so there are completely different cosine values all across, because same thing, it has to pass the vertical line test.